All right, welcome back to Mr. Richmond's laboratory, and the first part of this is going to be the fun math stuff. So let's talk equations first, and then I'll talk a little bit math, and then on the next video you'll get to work through the lab. So let's start with the math. We're going to be doing specific heat today in lab, and we're going to be utilizing this equation. Q equals mc delta T. Now, at first glance, if this is the first time you're seeing this, you might be thinking, why has Mr. Richmond put a triangle in my math? I don't think I like this. Let's talk about what all of these things are. So first, Q. Q is energy. And you might be thinking, why? Well, it's a Q. Well, think about the Q as quantity of energy. And that quantity of energy is being transferred. And we're going to measure that in joules. Okay? And then M. M is mass. We're going to measure that in grams. C is a little weird. It's something you have not used yet. It is specific heat. And specific heat is just the amount of heat energy that is required to take 1 gram of a substance and increase its temperature by 1 degree Celsius or 1 Kelvin. 1 degree Celsius and 1 Kelvin are the same magnitude, so we can do either one of those. Okay, and we're going to measure that in joules per gram degree Celsius. That brings us to this guy. This thing, the triangle, means change, specifically change in something. This one is temperature. Okay? So what we're working with here is the change in temperature. These are like best friends that you can't separate. They are together. Okay? We could also think about it like this. Final temperature minus initial temperature. But either way, we're going to use degrees Celsius to measure that today. Okay? And we're going to be using water. So the specific heat of water that we're going to use today is actually going to be 4.18 joules per gram Kelvin, which we know can also be degrees Celsius. Okay, so that's the equation we're going to utilize as we work forward here. The other thing we're going to need to know is we know that your energy is coming from food for you, and specifically when you're talking about that, we think about our food energy being calories. Our caloric intake is where our energy comes from. So I am going to tell you that 1 food calorie is equal to 4,184 joules. Okay? So the very first question is the one that I want to talk about. Question 1 on the pre-lab practice says, how much energy does it take? So energy is Q. How much energy does it take to raise the temperature of 2 grams of water? So the mass, I'm sorry that is coming in and out of focus on you, is 2 grams. And we want to raise it by 1 degree. So the change in temperature is going to be 1 degree Celsius. Okay? So based on that, if I think about my equation, Q equals mc delta T. I have M, I have delta T. I don't have C. Why would he do this to me? Now, you do. Right here. Remember, this was specific heat up here. So the specific heat of water is this. So that is my C. That never changes. That is what water is. The end. So when I plug that in, Q equals M, 2 grams, times C, 4.18 joules per gram degree Celsius, times 1 degree Celsius. Q equals, your turn. Q equals 2 times 4.18 times 1. All right, so you should be taking a calculator out and you should be plugging that in right now. And you should be coming up with an answer. 2 times 4.18, 8.36 times 1, 8.36. Now, if I'm thinking about what's happening here, if I just break this down based on my units, okay, I've got 2 grams, there's a unit there, times 4.18 joules per gram degree Celsius times 1 degree Celsius. Well, I've got grams on the top and the bottom. I've got Celsius on the top and the bottom. The only thing I have left is joules. Okay? So that walks you through the first page of material, the equation, and problem 1. Problem 2 and problem 3 are the same thing with different numbers. And problem 4, you're taking your calculation in 3 and you're going to follow the directions to convert it using the calories number that we talked about right there. Okay? So come right back. We will pick this up with the lab setup, and I will see you then.